Third International Physics Olympiad, year 1969, IPHO, problem number 2. Water of mass M2 is contained in a Cooper calorimeter of mass M1. Their common temperature is T2. A piece of ice of mass M3 and the temperature T3 less than 0 degrees Celsius is dropped into the calorimeter. Question A. Determine the temperature and the masses of water and ice in the equilibrium state for general values of M1, M2, M3, T2 and T3. Write equilibrium equations for all possible processes which have to be considered. Question B. Find the final temperature and the final masses of water and ice for M1 equal 1 kg, M2 equal 1 kg, M3 equal 2 kg, T2 equal 10 degrees Celsius, T3 equal negative 20 degrees Celsius. Neglect the energy losses. Assume the normal barometrical pressure. Specific heat of Cooper is C1 equal 0.1 kilocalorie per kilogram 1 degrees Celsius. Specific heat of water C2 equal 1 kilocalorie per kilogram by 1 degrees Celsius. And the specific heat of ice is C3 equal 0.462 kilocalorie per kilogram by 1 degrees Celsius. Latent heat of fusion of ice L equal 78.7 kilocalorie per kilogram, and take 1 calorie equal 4.2 joules. Solution for problem number 2. Here we use the following notation. Let T be the temperature of the final equilibrium state. T0 equal 0 degrees centigrade, the melting point of ice under normal pressure conditions. Big M2 equal to final mass of water. Big M3 equal final mass of ice. And M2 prime less than M2 mass of water which freezes to ice, and M3 prime less than M3 mass of ice which melts to water. So here we can discuss 3 different options. So first option is when final temperature greater than 0 degrees centigrade. It means that all ice and the water became water. The other possibility when everything became to ice, when T less than T0. And also we have possibilities when final temperature equal to T0 and part of ice, let's say that's M3, became ice and the other is water. So let's see what happened in each cases. First case, suppose that everything became water with a temperature greater than T0. It means that if we put here on the left side all heat which was taken from water and the calorimeter, we have T2 minus T multiplied by C1 M1 plus T2 minus T multiplied by C2 M2. This is all heat which was taken. On the right side we have ice. So first ice became to 0 degrees. It means that here we have T0 minus T3 multiplied by C3M3. That's total heat from ice from temperature T3 to temperature T0, plus all heat was taken to convert our ice to water, which is L multiplied by M3, plus the rest, which is T minus T0 multiplied by C3 and M3. This is heat what was taken to final temperature T. Second case. This is the opposite. So now we suppose that everything became ice. So it means that on the right part of this equation we have T minus T3 multiplied by C3M3. This is total heat what was given to ice, and that's equal to temperature of a calorimeter, T2 minus T multiplied by C1M1, plus the same for water from temperature T2 to T0, C2M2, plus temperature which was taken from water to converted to ice, which is LM3, plus the same for ice, which is T0 minus T multiplied by C3M2. So that was second case. And third case is when everything became in temperature T0. In that case we have from left side all heat what was taken from water and calorimeter to get zero temperature. That's this one. And from other hand we have the same thing for ice, which was taken from, which was given from temperature T3 to temperature T0, this one, and plus change of heat what was created due to change of mass M3. So here we have, if mass M3 became less than mass big M3 became less than M3, it means that part of this ice go into water, and in other case we got more ice. So it means that in this case we can take in account masses M3 from 0 to M2 plus M3. In other case it's not convenient. So let's see what happened in each cases. If we get data from part B and try to put them in our first and second equation, we will get a solution which are not allowed. So it means that in the first case we cannot get temperature more than T0. In this case we cannot get temperature less than T0. So it means that only possibility is third case. In third case we have this equation where we have to count everything except M3, because all other data are given. So from here we can find that this equation, and if we solve it m big 3, we will get this equation, which is 2.11 kilogram, which is a little greater than the initial 2 kilogram. It means that part of water became ice, but this is still less than initial 1 plus 2, which is 3 kilograms. So it means that this is the correct answer. So M3 belongs between 0 and 3 kilograms. So that was the solution for problem number 2.